The general solution would be the simplest in a lot of cases, would be to just get some monolithic frameworks. It can be Django, it can be something else for other technologies like, Spring Framework, for example, or Spring Boot if you want something that works better lately. But still, it will be just a big monolithic framework with a lot of batteries included. So let's design our monolithic application. That's just it. That's your design. You have an application, you build it. This is a single instance of it will be running probably. You probably will have some database or databases which you will connect and it will work. The general solution would be can be Django, it can be something else for
what is going on?
Other technologies like
it is.
Spring Framework, for example, or Spring Boot. If
maybe I have this open. Oh yeah,
works better.
I do.
Lately,
sorry.
But still it will.
I do.
Sorry about that. So you have database, and we will just add bunch of components internally in this application. So generally, Django application will consist of some ORM, Django ORM. You will build models on top of this ORM using this ORM API. You have controllers, a lot of them, and you have REST API to connect to the clients. And you have a bunch of batteries, basically libraries which will provide you some functionality for auth authorization, for notifications, for email sending, whatever. Django has a lot of them. You can also use some other libraries and stuff like that. And they all will be included in your monolithic application. As you can see here, two important things to note here. First, you still have a normal separation between different kinds of entities already. Even in Django application, even in monolithic application, you can clearly see controllers, models, and stuff like that. So your concerns are already a little bit separated, and binding is not that close between them, but still it is pretty close. They are bound on binary level, and this can be an issue in future. What else do you have? Maybe you will have some data queues if you need to offload some email sending to something else or processing of some events for collaboration. It can be something like Redis, it doesn't really matter. And again, you will provide just a REST API for your clients, any amount of and any number of clients. This is your typical Django REST framework-based application. Well, it's nice. It's already quite specific, and you can split up your work for the members of your team. But like this is just a server-side event sent by batteries. But anyway, what problems did we already solve with just this design? So from functionality point of view, we actually can provide most of the stuff we described in functionality list. So it will work. You can implement almost everything, if not everything, from this list. Local development and testing and debugging is easy and well known because tooling exists, it's well known, everybody knows how to use it. You will probably have a single Git repository with shared dependencies of libraries for different controllers or stuff like that. It's easy to maintain. Again, it's well known. Everybody does it for a lot of years. Nothing new is here. And onboarding, at least at first, is quite trivial because Django developers, if you have experience with Django, it's a good thing if you have experience with Django because it doesn't really matter from project to project. You can go to another project and you easily are able to adapt. Of course, it will have some quirks, and if it was designed poorly or maintained poorly, you will still have to adapt. And the longer this project was in development, harder it will be. So let's talk about problems and downsides of this approach. How do exactly we manage the team size? Because if it's a monolithic application and services are still closely bound, specifically, for example, ORM part is closely bound, it is harder for you to split up the work between multiple developers. At some point, you have so many developers that they're not helping each other because they have a lot of merge requests, because they change same models, for example, and they need to do it because they need to work in parallel. And this is a problem. How do we actually deploy and scale this application? Well, you have a lot of options, honestly, a lot of them actually. And you can deploy on a bare metal server just in a really old-fashioned way. You can buy some virtual machine in DigitalOcean, for example, and deploy it there. It will work again, but is it good? You will spend a lot of time doing that, and you will need to write some tooling or reuse some existing tooling. And this is different from project to project, and you will need to learn how to do it in a particular project. And scaling here is possible, of course. You can just run more instances of this application, but if you have some shared state in it and you want to have a cache, you will have problems with scaling. It's not that trivial, actually. Now, A/B testing is complicated and not scalable. And what is A/B testing? Well, it's when you want just 10% of your users to have feature implemented in one way, and other 90% of users the same feature but implemented in different way. So you can just see which feature works better for you, if they like it or not. And this is actually quite important nowadays. It's really hard to do it with a monolithic application because you will just need to deploy one instance, for example, with old functionality, 2 instances with new functionality. It is again possible, but you need to work around it a lot. And single instance will generally support thousands of users already. So you can't gradually scale it. You can't just quickly scale it out or scale it in. And it's really hard to bind particular user to a particular version, because if you have just a stupid load balancer, it will be hard to actually balance the request properly. All of the simplest solution for load balancing for monolithic applications are generally just get request and pass it to one of the free instances, and that's it. And all of them just go to the database, provide the response, and that's it. But if you want to do it gradually, it's a bit hard. It's hard to estimate costs because, again, single server will support 10,000 users, 2 will maybe support 20, but you will probably hit some bottlenecks which are hard to understand with a particular component, with a small part of your application. And because you have a bottleneck in one part, it's strange to scale up whole application as a solid monolith here. And again, when your project will grow, it will be harder and harder to develop it rapidly. More internal dependencies, more pull requests, more discussions. It's not that great. And personally, I have experience working and supporting a bunch of projects which were built like that in the last 10 years. And it's generally always about the same. They all, at some point, require complete rewrite, because it's just easier to rewrite it from scratch than to try to fix all of the legacy that was accumulated through a couple of years. And Australia, and we want our server to work in Australia, for example, still not working because we are focusing on European market, for example. We have servers in European market, and it's harder for us to deploy it to Australia. Again, lately it's not the major issue, but still, it is harder to deploy. You have to set up a lot of tooling around it. What can we do about it? Well, we can try using Amazon Web Services to do it, because we know Amazon is great and everybody uses this. And as you can see, it has a lot of services. Just one section here is actually opened, and they have a lot more. And the problem is, it's really hard to, if you don't have experience with Amazon, it's actually really hard to just get your monolithic application and just deploy it to Amazon, so it can help you with something. It actually requires a lot of DevOps time. But let's try to focus on the most important parts of the whole architecture of Amazon and overall amount of services, and try to understand which services can we use easily. So, first of all, when Amazon was just young, they initially just created virtual machines. And it was just virtual machine cloud. And the idea is pretty easy. A lot of people understand it quite well by now. You have just, instead of physical machine, you have a virtual machine, and the benefits are quite easy to understand as well. You can, first of all, you can clone this machine as many times as you want rather quickly. And this is a huge problem before. If you had a real server, the time that you need to spend to actually set it all up and maintain it and get all of the updates into it is huge. And if you can just clone already set up instance, it becomes billion times easier. It also has snapshotting, so whenever it works for quite some period of time, you update it, you do some work on it, you can snapshot it, and if something goes wrong, you can just restore it from the previous snapshot quite easily as well, and fall back to the previous version and fix something, which is almost impossible with just a physical server. And you can scale, because of that, you can scale horizontally, at least quite easily. You need more instances, just like that you have more instances. You just bought some more instances. And instances are various in size in Amazon, so you can scale more gradually. Instead of buying big physical machine, you can buy a couple of small instances, for example, deploy something to them, and it will just work again. And the great thing that I wanted to mention about Amazon, they actually have, they had it for quite some time, but right now it is actually usable. It is EC2 auto-scaling service. You will need to do a lot of configurations there, but it will be able, based on some metric of your application, to automatically deploy more instances for your application and undeploy some if you don't need them anymore, which already allows you to adapt to growing amount of users if it grows in a steady speed and pace, and it's already 10 times better than you should do before. So, and you can build some instances with any Linux base that you want, and in some cases it is important to be able to have particular version of binary packages there as well. Now, what are other things that Amazon provides which needs to be mentioned? Well, spot instances are a great tool also if you want to save some money. So spot instances are basically similar EC2 instances, but they cost a lot less generally, like 6 to 10 times less than similar in size EC2, just a standard instance. But Amazon can kill it at any point. Basically, Amazon has physical machines at some point. It has machines in data centers. And not all of the resources, physical resources, are always sold by Amazon. So they thought, well, if we have some resources, we can just sell them. And it works like some bidding. You bid on an instance, and if the price of this instance is less than you are bidding right now, it will work. If the price goes up, it will be killed. But the nice thing about Amazon, they will actually notify you 2 minutes before this instance will be killed. So you can actually adapt to it. And this is actually really useful if you want to create a system with some tests. For example, you need to run a bunch of tests. You deploy, with automatic scaling even, it can also work with automatic scaling. You deploy some instances, spot instances, you pay not a lot of money for that. And if it gets killed, it's not a big deal because end users will not be affected. Well, your tests will not finish. You will need to deploy them. You need to run them again. And tooling exists that automatically can do that for you already. So this is a good thing and a nice thing. And if you want to save money, you should look into it. Especially if we move forward, it will be even more interesting. Now, Amazon has really nice service called Elastic Load Balancer, which allows you to, like I said before, to balance requests between instances, but it also can be smart. So it can also, based on some text and some other things, a lot of things basically, you can configure it in any way you want. It can send particular user to particular part of your system. It can send users for A/B testing for a particular version of your instances as well. And also it will provide notifications and metric for auto-scaling. So you can see that if your load balancer getting to a point when not a lot of free machines are remaining, you can automatically scale them up and vice versa. And another mention, they, not that recently, but they introduced Beanstalk service, which is basically a combination of all of the services I've talked about before, specifically built for deploying old-style Django and other like monolithic applications. It will fulfill most of the things that you would need to configure manually because it understands how these applications generally work and what do they need. It's a nice service. It's, again, you have to pay some money for it, but it will reduce amount of efforts you need to spend for DevOpsing this and manually setting this all up. Again, you still will need to configure it, but the configuration is much easier there. So they also have a great set of database services. Like we seen before, in addition to your application code and computational part, you will need to store some data, your data somewhere. So Amazon provides Amazon relational database services for, well, relational databases. They have Amazon Aurora for, it's their own version of MySQL and PostgreSQL engines with a great configuration and nice support, and scaling is done pretty well there. They support also on commercial basis Oracle and MS SQL Server, of course, and their own additional fork of MySQL, which is MariaDB, if you want that. You have DynamoDB for non-relational data storages and key-value storage. They don't support out-of-the-box Mongo, which is quite popular, but for some reason they don't. I mean, the reasons are quite complicated there, but it doesn't matter, at least for now. They have Redshift for similar to Redis, but for metrics for aggregating the data, and you can query it with SQL, but it will optimize it for basically reporting and stuff like that. So you can analyze a lot of data in it, and it will scale automatically as well, and it will be quite useful for reporting. And they have Elastic Cache, which consists of Redis or Memcached, if you need to offload your state to some really fast working in-memory storage, which is quite important in any case when you are starting to scale your application horizontally, because you cannot store your state inside of the instance. You have to offload it somewhere. So with all of those services, like we have in red, and they will always be in red on all of these other slides, services provided by vendors, so in this case by Amazon. You have relational data services, you have DynamoDB, you have SNS and SQSs for queues, and then you have Elastic Cache. This should be enough for us for this application, and you can just deploy the same application and bind this to on one EC instance to all of those services, and you can have another application to bind to all of the services. And you can deploy as many applications as you need. You can, I will mention that, you can even deploy multiple instances of a single application on one EC2 instance, of course, if you want to. Generally, it's better not to do that, but you can if you really want to. Now, let's see what problems we solved so far. Well, costs are now understandable to some extent better, because Amazon provides you with a really great price list, and you can easily see how much you will pay. And you pay as you go. So if you had more instances for a couple of hours, you will pay more. If you had less instances, you will pay less. You can estimate. Problem is with the solution from before, when you just buy fixed set of instances, you understand, okay, each month I will pay that amount of money. Now you are paying various amount of money, but you still can estimate that. Scaling is possible, but still requires a lot of configuration, even if you are using Beanstalk. Auto-scaling is also possible. Blue-green, to some extent, is possible. Again, you will still have a completely new version of your application. Even if you have a change in one small feature, you have to spin up a whole new instance with this new version. Users in Australia are happy because Amazon actually has a data center in Australia. You can easily deploy your application or with any amount of instances that you need, scale that for Australia specifically. You will not have latencies and stuff like that. It will work well. But still, we have a lot of issues that we need to deal with. So, like I mentioned, Amazon has various sizes for virtual machines. And they are not that gradual as well. So they have a couple of tiers, and they're small, not that small, and big and very big, basically. And it's hard for you as a Django developer to actually understand and decide which instance should I use. Should I use smallest one? But smallest one is not enough, especially on a peak traffic, it will just not fit. And if it's bigger, generally you don't need all of these resources from one instance. And so you are wasting money anyway. It's not that great, again. Scaling is too crude because of this. Your code in Django, even though you have this, multi-instance environment set up, it's still coupled quite closely and shares state, and you need to deal with this. And all of the problems we had with monolithic applications are still here. You still don't have proper feature toggling. You can toggle them dynamically here, mostly. Of course, you can, like if you really want to, you can design your application internally, so it will allow you to do that. But Django, from out of the box, it does not provide you with great tooling for doing that. And you probably need some UI, so your manager can toggle feature on and off dynamically and sees how many users will see it and how many users will not. And then with this architecture, you still need to redeploy an instance if you want to toggle some features. Deployment is slow, because even though spinning up of virtual machine is quite fast comparison to setting up a just completely hardware server, still your application needs to fire up all of the caches, load. It's not that quickly. And in a lot of cases, it's important, especially when you have traffic spikes. For 2 hours, for example, you should scale up 10 times, and then you should scale down. Or you are not paying proper amount of money. You pay too much. Or you are not quick enough to actually handle the many requests, so your users will suffer. And if you have a successful marketing campaign and 10,000 users will try to use your new to-do list startup and then nothing works, that is really bad. And it's really hard to be prepared for that with this kind of setup. And you still, even though you are trying to offload some of the complexity of the deployment that before your sysadministrators, DevOps would do, you still need to learn a lot of things to do basically the same thing, but now on Amazon. It's not that easy to actually set it all up. It's not like you go to an interface and it will work. Auto-scaling is hard to set up. Permission groups are also hard to set up in Amazon. A lot of things that will still require a lot of technical support and knowledge. And we already have a possible vendor locking from Amazon. It's not that hard right now because we are using just small amount of Amazon services and we just deploy virtual machines, and a lot of other providers allow you to do pretty much the same thing. But if we use Beanstalk, yes, you are already vendor locked because Amazon will do it for you. If you want to switch to something else, you will need to completely redesign all of the deployment part. So that might be an issue for some people, and you have to think about it. But anyway, this application worked, but we probably need to change something about it. And a lot of people thought the same. And a couple of years ago in Poland on a conference, people started to use the term microservices. Even before that, Docker appeared and introduced containers. And the idea of the containers was, well, it's really hard, again, to maintain real operating system, like to set all of the dependencies up, all of the binary dependencies. Well, can we do something about it? Yeah, we can use virtual machines. But virtual machines, generally, if you create a virtual machine, in most, from most vendors, you will still to set the amount of memory it will use, like strict it. And again, you waste some resources in this case. And this virtual machine behaves in a lot of ways like a real server. You need to set it all up, and you still have some things which are not great. So people thought, well, we can actually create containers which are starting super easily. They can be scaled really easily. They will use only the amount of resources that they actually need from operating system. So they are a lot more gradual and actually fun to use and easy to use even locally. At least that's what people thought at the time. And again, when you can create basically a new instance with your operating system, with specific binary packages, specific SDKs installed on it, it's actually, you think, okay, so now I can have something written in Python, which takes as little resources as possible, and something written in Node.js because, well, we didn't have this library in Python, but we have this library already ready, but it's written in Node.js. But we want to use both in our application. Well, not a problem. You deploy two containers. One will have Node.js service, second will have JavaScript service. And you can do a lot more services like that. And this is nice because right now you are not thinking about all of the binary restrictions. You just think about which APIs these services provide to you. So it's natural for you to split up your monolithic application to a bunch of services. And each service is basically a process or just a piece of code, just an application. It can be like each service like that can be, in fact, a small monolithic application. And Django does not work like that very well. But a lot of frameworks work like that very well, like Flask, for example, because it's specifically designed as a really small platform for building whatever you want with HTTP interface. And a lot of people use Flask right now. In latest versions of Python, we also have IO HTTP with async programming, which is also quite promising. I really am a big fan of it. And you can do the same with it. It's really lightweight. Other languages and JavaScript also provides really small services, so you can just create some simple API, HTTP or REST API endpoints, and it will work. But if you look at this, you still need some place where you store your data, and you still have some data queues. And now you need to resolve another problem. Before all of these services, and you could have implemented all of those services inside of a monolithic application, honestly. But now they are on separate instances. They are in separate processes, and they are even on separate servers, separate containers, and separate physical services. So in order for them to communicate, they need some sort of transport layer. And a lot of services can communicate with just simple REST APIs. But in some cases, it's not suitable because you need to offload a lot of state from your service temporarily till another service will be able to handle it. So you have data queues, like you can use Redis, you can use a lot of things here, to be honest. But good thing about it, that even if you just look at it, all of those entities are quite loosely coupled already. They just communicate via APIs or data queues. So you can implement it on different languages even. So you have multiple code bases and they are simple. So you can scale up your team quite well with that because people will conflict with each other less than they did before, generally. Another idea of microservice design is to actually allow some of the clients to directly communicate with public data storages based on some firewall, well, based on some security rules. And this will offload the load from your services here, from your computational layer here. And this architecture is nice. It is considered to be viable, quite viable at the point, but it already exists for quite a long time, so a lot of people see a lot of issues with it as well, especially from testing point of view. Because before, when you had monolithic application, it was quite easy to test integrational, to basically write integrational tests. And with this architecture, it's harder, because you can have two situations. For example, this service has an API. And this API, like this, another service was communicating using this API. It has some integrational tests for that, and it has some unit tests. And if you have a unit test, you don't have to, and you probably don't want to fire up this service. You just want to test this service in isolation. So generally, you mock this one out. And when you mock it out, you have the similar interface, but it's not really the same interface. It's just similar and does similar things. And then somebody from your company, and you don't even know this person because your team with microservices can be huge already, changes the interface here. So it breaks communication in production for you, but your tests still work because these calls were mocked, and the mocks are still old, and mocks still have old API because mocks are actually implemented on this service level, not on this one. And person who did that change had no idea how many mocks are implemented in other services. And this is a huge problem actually right now. And various people try to solve it differently, but general solution for me that I like the most is to have another entity and which stores integrational test for both services, because not any of those two services should be actually responsible for integration between them. So you have proper integrational test and integrational test system somewhere else, like a service again, and it knows about both of those services and it tracks all of the changes. People even trying to analyze the code of schemas and see if integration can be broken between them. But it's actually, it complicates things a lot, as you can imagine. But anyway, let's go back to Amazon here. If you want to deploy your microservice design to Amazon, Amazon, of course, provides you with a lot of new services and tools. First of all, Elastic Cloud Service, ECS. So it is a really powerful thing. It's nice. It was designed for you to deploy mostly Docker images on top of it. And it works in a really easy way. So you actually still buy some EC2 instances, normal one, spot one, doesn't matter, and you combine them into a cluster, this Elastic Container Cluster. And now you have tooling to deploy your application, actually your service, containerized service, in this cluster. And this cluster has some capacity in it, based on the capacity of all of the, like the sum of capacities of all of your actual instances. And when you deploy, it will choose the instance which has some space on it and deploy it to that instance. You don't specifically think about which VM you are deploying to right now. You just deploy to the cluster, and that's it. Which, of course, makes a lot of things easier, because you don't have to manage your EC2 instances. But it's not completely true. You don't have to manage them that rapidly, like that quickly, because you can buy a lot of them and your cluster will be big. And when you need more resources, you will deploy more containers. But you pay a lot for that. Again, you pay for even capacity that you are not using right now. And this is actually a really huge misconception which people have with ECS. They think if it's elastic, it will be easy for me to just create a cluster and deploy and it will grow. No, not automatically. But like I mentioned before, we have automatic scaling for ECS instances, for spot instances. So at the end of the day, yes, you can set it all up and provide some triggers from your ECS. So when you deploy a bunch of new containers, it will create new virtual machines, add them to your Elastic Container Cluster, and so your cluster will have more capacity. Amazon understands this problem, of course, and they created a service they call Forgate. It is now was tested, as my recent memory, in America, and it soon should be available in all data centers. And Fargate is basically automated scaling for your EC2 instances, and basically you don't even have to think about any EC2 instances at all. You just have Fargate cluster, you deploy into it, and you can buy more resources, you can buy less resources in it, and it will also, you can make it to scale automatically, which is almost perfect. Like, if you don't have to think about actual virtual machine instance, you have to think about your container, which is really small. It's almost perfect because features are deployed as containers. And to provide communication between services, between containers, Amazon provides simple queue service, which is really simple queue, just actually queue service. It has queues and you put data into this queue and you can read from this queue. It has SNS, which is simple notification service. It has topics and you can push the notification to it, and you can have multiple readers which are going to be notified. I will show you in a bit how it works. And that's pretty much what is important here. They have a bunch of other services for various tasks. For example, if you need high performance queues with small events, they have something else. And if you want to process video traffic, for example, They also have specific services for that. But the general idea is similar. So now, if we look at our microservice architecture that we had before, we can actually map it to Amazon as well. It is similar to what we have, but let's see. AWS DynamoDB for shared state that we can directly map to our client. For example, in every application you have a lot of just dictionaries, countries, flags, avatars, stuff like that, which is mostly static or changes in a really slow manner. And you don't push anything from client into it, but you read a lot from it. So why not make it public? And Amazon provides you with API, client connects to this API, everything works. Now, for relational databases, you are still using AWS Aurora, relational data services. You have, before it was just your own service, but in Amazon, actually, simple mail service exists. And it's really nice because it scales as well, and it avoids a lot of issues with mail sending. Sending mail is still a pain if you don't use existing services. There are a couple of alternatives outside of Amazon which are similar, and they are software as a service. So you can use them. Again, like I mentioned, SNS and SQS for queues and communication between all of the service. And then you can still communicate with simple HTTP APIs between them, but for some cases you communicate with SNS and SQS. And now your services are just put into Elastic Container Service, and each of the services can be scaled independently from all of the other services. So if you see that your notification service needs rapid growing, you automatically or manually deploy a bunch of new notification service instances, so they will offload the queue that you have here. If you have collaboration service, the same. But probably, your registration service does not need to be scaled that much. So you scale your application in a gradual way. And another thing which is good here, that you can replace services with different versions. You can have multiple versions of the same microservice running in your system, which allows you for really good A/B deployment. You may deploy as many different versions of your services as you want to. So let's summarize it. We solved the problem of cost, because right now, instead of just deploying the whole application altogether, we can just deploy more services and scale in a more gradual way. Still not as gradual as we would want to, but it is already a lot better. We can quickly adapt to traffic spikes, at least average traffic spikes, with scaling up particular services out of every service that we have, just a couple of them. And feature development can be scaled as well, as team size can be scaled, again, because services are now more decoupled, and communication between services is event-oriented already. It is easy to introduce more services. It is easy to introduce more developers. And these developers don't need to actually know everything about your system. They need to know specifics of the services they are directly communicating with. And if you have something like SNS, so simple notification service with topic, one service can just provide something to this topic, push some events, and it doesn't really need to know how many consumers will read this topic. You just produce data, and sometime in future, somebody will create service which also consumes this data, and you don't need to think about it too much, which is really nice for long-time projects, honestly. But still, we have a lot of issues here. It's not a silver bullet again. Dependencies are now harder to maintain, because in a monolithic application, what you generally have is something called miscellaneous library, and this is your big pile of code which is reused between a lot of controllers in Django application, and it helps you a lot, and everybody understands it. Everybody knows this, the core. Well, even if you have microservice architecture, you have a lot of services which are similar in design. They just do different business logic. For example, to-do list and particular editor for single to-do item. they work with the same data storage. They communicate with the same services. They do a lot of things technically in a similar manner. But they still need to share some code. And this is a problem for microservice architectures. You actually share code as libraries in them. You package your code as a library. You deploy it to some artifactory service like JFrog, for example. And when you build your application, you get it out of the artifactory and just treat it as a normal library like Flask or any other third-party provided library. And this is nice, but it makes it harder to keep it all, up to date. And I had issues when a couple of services in a big system used one version of your own library, and another services used different version of your own library because nobody maintained them for 2 years. But other new services were maintained. And as time goes on, if you have some binary dependencies as libraries, it's getting actually harder and harder to keep it all together. And again, if you have multiple services, some of them will be not maintained at all for a long period of time. And all of the dependencies will be obsolete at some point. And then some security issue happens in this third-party library, and you need to fix it. And then you suddenly find yourself in a situation when you need to change 5 different services, but they have different versions. They need to be migrated differently. And this is a problem. And nobody actually knows how they are working because nobody worked on them for 2 years. This is actually a concern. And as microservice architectures are actually only exist for a couple of years, only now we are starting to get to that point when we have these projects which were built on this architecture and right now are having these specific issues. So not a lot of people actually understand what to do with that properly. Like we have ways around it, but we don't have receipts to how to fix it properly and quickly, and tooling around it as well. So again, like I mentioned, we have test issues, a lot of them. We have development and deployment tooling already for them, but it is immature. So if you compare your robust IDE, which can run all of the tests, it will show you all of the graphs, it will deploy if you want with just single click. Well, in microservices, it's actually quite hard to even run a couple of services on your own machine. Even though you have Docker, right? It should be easy because service should be agnostic, it should just run. But if service has a couple of other services, for example, SNS dependency, you need something on your local machine which will emulate SNS. And Amazon, unfortunately, at this point does not provide you with a normal set of locally runnable tools which will emulate your normal Amazon environment, which is a huge problem, actually. One of the biggest problems with Amazon right now. It is kind of hard to develop service locally. But you can argue that, well, but why? I just want to focus on my particular service. It has an interface. I know that it should get some events from something and with some format, with some schema, and it should push some events from to something, and that's it. And it's a good approach, again, in theory. In real life, unfortunately, it's quite often you have to debug 2 services or change 2 servers together because they are logically bound too much that you cannot avoid it. And this is a huge problem for onboarding, actually. Because when you have new people, they try to start it up, they don't understand even, and this is another problem. When new person comes to your team or your company, like recently I had a project with almost 200 of different microservices, and they didn't even have any documentation because you don't document the system as a whole because it's in microservice architecture it feels like who is responsible for whole system? I'm just doing my own microservice, and maybe I will document it, but it's too small and easy. Why would I need to document it? Because it just has 2 API calls, and they are obvious, and you have some schemas, and that's it. And in reality, after a couple of years, you have this pile of microservices. Some of them are obsolete. Some of them do the same things that others do. And if you don't have a proper way to track all of this, you will have issues. And generally, from what I see, a lot of projects have this issue because nobody is responsible. Nobody is prepared to be responsible for that. Again, well, it's a lot of things that could be done. A lot of tooling are actually appearing right now. Amazon, for example, has this thing. I will actually mention it later. It's called Amazon X-Ray, which basically tracks the events when they come from one service to another. It logs all of the events. And if you have all of the logs and you can see that, okay, this server sent 5 events during this hour to this service, and this service after that sent 5 events to another service. If you have all of this information, it is possible to visualize all of, like, whole graph. And so you have a visualization with event types and stuff like that. But honestly, X-Ray is really immature. Like, if you try to use it, you will have a lot of issues with it. You will like look at it and it's like, yeah, it is visualizing something. But honestly, if you have 200 services, it will be like a mesh of, you know, relations and stuff like that, lines, and it's not even scalable that well. Basically, it's immature, like I said. The tooling is just not ready. Actually, that what will be one of the last things that I will say about it. I will come back to that. Now, vendor log right now is very substantial because, as you can see, a lot of things are Amazon right now. Even this thing is Amazon. But for container service, it's not that bad because a lot of other providers, if you are Docker-based, they will allow you to deploy Docker. But all of the tooling around scaling, around deploying, actual deployment, is not provided by them. Like, it is different in Amazon than in other systems. So it is a problem. And there are a couple of interesting solutions to that. One of them is called Kubernetes, and it became quite famous lately. And it is basically designed to be platform agnostic. So you can have an infrastructure, the microservice and cloud infrastructure, which is agnostic to any provider, including Amazon. But it is a bit immature again, but it grows substantially. I would suggest everybody who wants to build your own microservice architecture, and you don't have to go to Amazon. If you don't have to go to Amazon, you would probably be good if you go to Kubernetes right now, at least investigate it. Now, this is it. And now the latest and most interesting beast on the market right now, serverless. Like 2 years ago, microservices were like, it's great, it's the solution, perfect, nice. Now it's serverless. And the concept is really interesting. First of all, you don't need to have Flask almost ever. You don't need to have web framework. You don't need to have any framework. You can write on pure Python, pure JavaScript, pure Java, pure .NET, whatever you want. The microservice right now becomes even smaller. It does super simple things. It is called function in some ways. And the design with serverless will look similar to microservice design because you still have a bunch of loosely coupled components. But instead of services, they are now called functions and function groups. So as you can see here, you don't have just general things that combines them all together, at least for now. Functions, you can think of functions as, it is, you know, like it's a stretch to call them just functions. They are not functions, honestly. They are just really small microservices, generally with a single task to do. So they are getting invocated as a function does. They receive some parameters. They do some work. And they may invoke other functions or return some parameters back to you. That's it. That's what it's all about. They don't have state because your microservice will be running constantly, right? You will deploy it and it will run. So it can have some internal caching, some internal counters and stuff like that. With function, you don't do it. You just create a function, you invoked it, it responded with something, that's it. But in the other ways, you can do your design in a really similar fashion. But a lot of APIs right now, which were provided as software as a service before, are starting to provide you APIs as functions. So you just call them, and it's really simple, and they will just do something else, like do some simple task, and that's it. But the general idea behind functions is actually scaling. As I mentioned, if you have a microservice instance, you will run a couple of them, and they will run. And it is easy to scale them up and down. Again, you can scale them down completely. But when you're scaling it down, when suddenly you need this micro, you can completely remove it from your system, right? But then, what if some other server tries to call its API? It's not there. No instances are there. So you need to deploy them first. And that's the problem. So you at least have one microservice running constantly. And again, it takes some resources, and you pay for them on Amazon. So you want to avoid that. And Amazon provides you with this feature called Amazon Lambdas. And this is a quite simple service which just supports following things. It supports automatic scaling. And right now, scaling is actually automatic completely. And it works like that. So if you have a function and it gets invoked, Amazon deploys, when it gets invoked, it deploys it, and it starts doing one particular thing. If, while it's still alive, somebody else invokes the same function, and this is busy right now, Amazon will deploy another one. If both of them are busy and somebody invokes this function, third instance will be deployed, and so forth and so on, till you get your cap that you can, manually configure, like the top amount of functions which can be invoked. And the function can be run only for 5 minutes. So it can do pretty long task, actually. So the whole invocation of single function can be long. And then it will get undeployed automatically after that. And another thing that is important, it can be set up in Amazon automatically to be triggered by event in some topic and SNS service. So you don't even need to write any service to invoke it. You can be just subscribed to some topic, and you don't care who will put a notification in this topic. It will be invoked when you have a new notification. And multiple functions can be subscribed to the same topic and SNS. Another thing which is interesting here, you have in Amazon and in a lot of similar systems with Lambdas and serverless, you have API gateway. And what it does is just a web service, basically your web server, which has HTTP or HTTPS interface. And you provide a configuration to it. And you say, OK, when somebody goes to this URL with these parameters, with the, for example, post request, this function should be invoked. And when it comes to another endpoint, another function will be invoked. So you offload your routing configuration from your services to the Amazon gateway service. And if you have 10,000 people clicking on your link, it will invoke as many functions as needed to fulfill all of the requests. And another optimizational thing, if the function executed just now, it's not getting undeployed immediately. And if somebody will invoke it again, the same function will be invoked. It will not be redeployed again. So it will be immediately invoked with new parameters and will return the results. What is great here? Well, first of all, you don't need containers at all. You don't need to manage containers. You don't think about requirements of these containers. You don't care. You just select runtime. And runtime can be a big list of runtimes which are supported. Different versions of Python, JavaScript, Java even. And you pay for the time this function is actually, for amount of milliseconds this function was working. And the price is quite cheap here, generally, if you, in most cases, are not invoking it. But if you are invoking it a lot, and this is like some function is constantly deployed, it will cost more than your typical microservice with container. So you need to be careful a bit about that. But the good thing about it, it will scale almost indefinitely as long as you need it. And scaling is quick. And in a lot of cases is important. With Java, you may have some issues. people reported that some Java-related functions were invoked after 2 minutes only, after the actual invocation. Because in order to do that, Amazon internally needs to deploy new virtual machine sometimes, not always, but sometimes. It needs to deploy Java is basically Java runtime, and Java runtimes, as we all know, starts slowly sometimes. So yeah, Java is not great for that. But again, if you have a, we have a trick for that for Java actually. You can ping your function each 5 minutes or 10 minutes. So it will get invoked and it will get deployed. But you will pay a little bit more in this case, you know, and it's always a compromise here. It's a really young technology. Again, not a lot of tooling around it exists right now, and specifically if you want to just use Amazon Lambdas. But it's nice if you want to scale your application in a really granulated and controlled way. And if you really want to save resources. Some big companies report that they saved up to 10 times, you know, like they paid 10 times less money than they paid before with just microservice architectures. And I'm not going to draw a whole architecture because it will be quite big if we do it with single functions. But this is just an example of how it will work with just our item create, replace, update, and delete for to-do list, for example. So generally, the approach works like that. API client makes HTTP request to gateway. Gateway finds the proper Lambda function from the list of mapped Lambda functions. It creates a SNS topic item. For example, new item was created. Let's look at this scenario. New item was created. I want to create new item. This gets to SNS topic as an event, like some user wants to create that item. And 2 lambdas will react on this. One will start working with database and download it to the database. And another will send you a notification. So this topic was created. If somebody subscribes, many users can be subscribed to this event, to this Lambda. And you have notification function as a service. It can be also provided by some third party, for example, for iOS or Android. So you can receive notifications. They will be subscribed for the invocation of Lambda, and either directly, or if they are in Amazon, or via similar queue, some system which you can post something, and then something will read from it. But general approach will always be similar to that. Again, what is scalable here? This part is scalable. DynamoDB is automatically scalable to some degree. SNS topics are automatically scalable. Notification Lambda scalable. And API gateway is also scalable with load balancing. So you have a full stack which is scalable. And the great thing about it, you don't really need to think about scaling anymore. You almost don't need to think about it again. Almost. At least you are not thinking even about not only virtual machines, not even about containers, which is great. So costs now are really well controlled. You pay per invocations. It will scale automatically and no configuration needed. Features right now can be also implemented like with microservices as a set of functions. And you don't actually need to have blue-green deployment anymore because you don't really deploy that as in a normal sense. You just add new function versions, you have some filters, and you provide all of the logic in your code and in the functions themselves, which function should respond to which type of the event, which version of an event. So feature toggling is very simple, but you actually need to do it yourself here. Like, because you don't have proper deployment, you will have to provide more business logic on your application level. And again, less framework we have, you know, more code we actually need, more business logic, default business logic we'll need to provide. And if you look at the function like that from the very far, it will look like a monolithic application because it will contain a lot of functions which are communicating with each other and they are contained in some environment. Before it would be Django application. Right now it is Amazon Lambda environment. But the general set of problems might be similar here. Of course, you will have nice scaling, which you will not have in your general Django application. But still, some of the issues exist. But still, some of the services nice services are already implemented, and a couple of them which are quite great, and everybody should use. If you use not even lambdas, if you only use microservices as well, it would be first one would be Auth0, because it actually resolves a lot of code you need to generally do for authentication, authorization, single sign-on. A lot of things is done there. It's great, actually. I love those guys. The company is really smart. Yeah.
What do you think about their pricing?
It is okay, actually. To be honest, if you are scaling up your authentication as lambdas in Amazon, even, it will cost comparatively similar to what they do. And they are designed for large services, because when you have large amount of customers logging in, reauthorizing, if you have a large amount, yeah, it will be similar, actually. You will pay more than you will pay if you build it manually, but again, this is the whole idea. You don't pay for existing. Functions as a service are quite similar to what libraries in Django would do for you. You know, like this is the same offloaded dependency to something, to some other company. And because of that, you have more dependencies generally. Because you don't want to implement everything with just simple lambda functions. It's hard, it's slow. And architectures and systems which are designed around lambdas are generally rely on third-party solutions a lot, like Auth0 or a lot of other systems. And when you do that, you are first locking yourself for these services, and second, you will have another dependency which may break at any point. And that's not that safe, honestly. Tooling is bad, let's be honest. Onboarding is also quite hard, because if you have a developer, how do you debug all of this locally? Because before you would have a monolithic application, or at least a couple of services you needed to fire up. Right now, you have a bunch of functions. At any point, any function may try to invoke any other function. You still need to replicate SQS, SNS, whatever services you provide. And if you rely on third-party applications, libraries, functions as a service, you still, like, if you want to test them locally, you need something similar to that. You will generally mock it, but you will have the same issue. Yeah, you mocked it. It works. But the API changed and nothing works in production. But well, it works locally for you, it's nice. You know, it's a problem. And people solve it with just schemas, you know, like, so tests are actually downloading the schema from the provider and compare the schema to the schema you provide locally for your mock. And now you need to maintain the schema. And it's also a lot of efforts if you have a large application. So not always great with long projects. Now, there is another thing called serverless framework, which is quite popular right now. It is even more popular than just Amazon Lambdas, because people thought, well, all of the issues that I mentioned, lack of tooling and stuff like that, maybe we can do something about it. So they took some JavaScript and decided to create framework, that they call it framework. But actually it's not a framework, and they tell, if you start reading the documentation, it's a development toolkit, and basically it's a CLI tool, command line, you know, client, mostly. And they just provide some of that, you know, some concepts, just general high-level concepts for you, which they can generate. And they provide nice tooling so you can easily deploy your functions from local machine to any of those providers. And they support a lot. They support Amazon, Azure, Google, OpenWhisk, Kubernetes, Spotins, and WebTasks. And they also provide their own implementation of Event Gateway. And the way Event Gateway is a thing that allows you to link two or more providers together. So Amazon has SNS, right? Simple notification service. But what if you want your Google Cloud to receive the notification from SNS? So with Event Gateway, you can do it quite easily. And the same you can do in any other combination of ways, which allows you to have a nice, you know, distributed architecture between even different cloud providers, if you want to. And what Serverless Framework is trying to do is to make it easy for you. It will cover all of the differences between those cloud providers as much as possible. For example, in OpenWhisk you have this thing similar to Lambda, and in Amazon you have thing Lambda. API is different, but with if you write your code and configuration with serverless framework, you can just write it once, and it will be able to easily deploy it to any of those clouds. In theory. In reality, APIs are still sometimes not compatible. And when they are not compatible, you will still have to adapt. But at least you have a normal tooling on local machine, you can quickly deploy them. And I want you to look at the kubeless here. Kubeless was designed as a Kubernetes cluster for actually local machine. So this is the solution which allows you to emulate whole Kubernetes cluster with all of the microservices and functions and lambdas in it on your local machine. And serverless can deploy to the kubeless, which should make it easy for you to solve this particular problem with which I was talking about. How do you actually test the system as a whole on your local machine? All of the functions, how they communicate, and how do you run integrational tests? Well, that's how. You deploy it to the, instead of Amazon, you deploy it to kubeless. Amazon actually, I had some information about that. Amazon is actually soon going to release something similar. They want to do it. They want you to be able to locally emulate the whole Amazon tooling environment and test it, which would be nice, of course. And honestly, I'm not even sure how people are living without it till this point, because it is really hard without this tooling. So, I'm going to show you actually the sample of this to-do list application, just a part of it, implemented in Python and designed to work with, come on, designed to work with serverless. So this is your typical serverless package. It's a project. It's not a single function. And a lot of people actually making a mistake. They actually create a Git repository for each microservice in the project. They create a Git repository even for each function, because they want to completely separate concerns. You know, they want to actually even revision control systems not to be involved in, not to, you know, couple those systems. But it's generally it's a mistake. You don't want to have 1,000 repositories in your team. It's normal to have a single one, especially if the functionality is related to a single project. It's okay to split them up nicely by directory, so you know it's not a mess of just JavaScript or Python files mixed all together. It's nice to just use simple logic to split the code, but it's nice to have a single repository. Some companies actually, which is quite bizarre, they have single repository for all projects that they do, even huge projects. They just have single repository. And on the bonus side, they actually, remember how I mentioned binary local versions of your local libraries, which may be different in you deploy them as in Artifactories and stuff like that. So companies solve it by just having the libraries in the same repository here, the source code for those libraries in the same repository. So if somebody changes this, it will immediately break all of the tests and all of the services, and it's easy to test that. And a lot easier to see, even if you just download the whole set of projects that your company has. It's easy to see examples, it's easy to see versions, it actually makes sense. It's a huge problem in microservice architectures and project management right now, when people think, well, people should not know about other projects if you work on single one, because you know you should not be concerned by it. Yes, you should not be concerned by it too much, but why are you restricted of this information? It will help you to actually work in a company-wide way instead of just creating your own things here. Anyway, let's get back to the example. So this is a really simple example, and the important thing here is the serverless YAML file. So let's look at it. It is just a service name, version of the serverless framework here, plugins, and for Python to work in serverless is all about plugins. They just have plugins for everything. It's just how they build. It's a micro plugin architecture, if you want to say that. So this is just for Python to work. This is the definition of your package, and it just excludes some files that you don't need to deploy on actual production. For example, local node modules, IDEA configurations, and stuff like that, obviously. You don't need to deploy even those. And then you describe your provider. So you want to deploy to Amazon. You want your runtime for some reason to be Python 2.7. You define the region in Amazon. You define environment variables. And now it gets a bit complicated because this is the Amazon specific thing. And this defines roles for the resource. And the resource will be defined further. Basically, it is integration with DynamoDB here is defined. Like your environment will need to be able to communicate with DynamoDB. Now, you define your functions, and as you can see, it's quite easy. So you have create function, and handler is here. This is just a path in your repository here to the particular Python module. And this is which events will be used to trigger this function or invoke this function. So event is HTTP, and pass is to-dos method is post course through. So basically, what it does, it's a configuration of API gateway, like I mentioned, HTTP gateway in Amazon. So whenever you have HTTP request, some service, some big HTTP servers, global lives always, and whenever somebody touches it, it invokes function with this configuration. So it compares if the get path is to-dos, and if method is post, and if it is, it will invoke this function and will send all of the payload into this function to process. And you have more. You have list, get, your typical CRUD set of operations. And you can have parameters here. It will extract them from your URL. It is similar to what you would have in Django, route configuration, any framework, what you will have. But you have this here. And finally, you have resources, and there are a lot of them, might be. But for example, you need to use DynamoTable. Because in order to do CRUD operations, probably you need a database to store them. So they decided to use DynamoTable. This is the definition of the type. This is some other configuration how this particular DynamoTable is configured. Doesn't really matter for us. Properties, schema for this database, and how many capacity units and write capacity units exist. This is a part of Amazon configuration for the Dynamo, basically. Whenever you create a table, whenever you set it all up to scale and stuff like that, how many requests you can do per minute, all of the configuration is provided by Amazon API. So of course, if you are deploying to Amazon, you need to provide Amazon-specific API. And you provide a table name from the environment here. So basically what it will do, like that's it. The whole configuration is here. And the code is here. And the code is really simple, as you can see. For the create, it's just your Python function, which loads something from request. It checks something in data, and it returns as object the response code. And it will be consumed by HTTP gateway and constructed. The normal response will be constructed, and everything will work like it would work with just a normal web service. Now, if you look at it, this looks like your typical, application with all of the just simple functions. And each function is in a different Python package. You don't have to do it that way for the most part. You can combine them and provide a more detailed passes, but it's like the better way to do it, what they at least think is better. Is it good? Do you like it? Well, I don't know myself. It seems nice. It seems nice that you don't have to, you don't see any configuration about Docker here. You don't see any configuration about containers, ECS, scaling, nothing like that. Some configuration for database, because it is specific for Amazon. And that's what I meant when I said, well, they are different, so you cannot provide the same configuration. You cannot deploy this to other cloud provider because they don't have Dynamo, basically. And this is a problem again. If you want to do it locally, if you want to test it locally, you are out of luck, unfortunately. You need to do environment-based configuration, and for local environment, you will need to replace Dynamo with something else. And it gets complicated quite quickly again. So yeah, for local development, not that great yet. But still better than nothing, I guess. Yep. Sure. Yeah, you're right. For DynamoDB, you can install the local version of DynamoDB, but you need to install it because yeah, I can. But how does this serverless framework will know that you need to deploy it locally? It will be a problem because your version of Dynamo will not be supported by Amazon environment, and this is the definition for Amazon. You know, in this file, you are defining how Amazon should provision your DynamoDB. Of course, you can install it locally, but you cannot use the same configuration probably. And again, that's an unfortunate thing. Anyway, let's summarize everything and complete this. So microservices are viable at the moment and good to use and simple and not that different from what we already know. Serverless, in my opinion, is also viable, but what I didn't mention is that nobody restricts you from mixing those. So for the parts of your application which require immediate scaling and super granular scaling and does not get executed often, for example, for the email digests each week, and they need a lot of resources to do that. But you don't need to have any services to do it constantly running. But you can introduce Lambda, which will be executed as many times as needed with any amount of deployment instances as needed during this period of time when you actually need to send a lot of emails. And you can do it in any way you want. So you can scale it how much you want. And what I don't like about serverless, again, it's not really ready for this mixed environments. You can do it again, but it's mostly about Lambdas right now. And I don't like that, honestly. But if your infrastructure or part of it can be abstracted as just a set of Lambda functions, sure, this works quite well. If you actually have this requirement to migrate between clouds, also good. And specifically, if you have the need to use some services from one cloud and some services from the other cloud, API gateway from serverless would be a good starting point for you. You define some functions, you define some API gateway config, and you have connected your two clouds and two different providers quite easily. Basically, provides the software which reads this serverless YAML file and uses APIs of cloud providers to deploy Lambdas to them. And
okay, so it configures in Amazon?
Yes. Yes, it configures Amazon API gateway, it configures Amazon Lambda deployments, it configures a lot of things. And it is developed quite fast. So a lot of other plugins will happen. You can read Serverless Guide, I highly suggest it. It is nice. You can also read 12-factor manifest, because microservice architecture is mostly built on top of 12-factor. And Serverless Guide is quite similar to what I was talking about, but is in larger details, and it's quite big and huge, and is not completely finished yet. And they're doing that. If you want to help them, all power to you. This is a nice technology. It's an interesting idea, and to apply to long-living projects and a couple of projects that I'm working right now. And it worked quite well. Like, we actually were able to avoid a lot of problems here. Our infrastructure is mostly microservices, not serverless though, yet. But we might introduce serverless. But we want to introduce serverless on demand. You know, if you want serverless functions, sure. But your architecture should not be about serverless. In my opinion, personally. And we will release quite soon, I hope, the whole to-do list example from this, like actual example of whole startup with similar to Trello or something like that, implemented on top of the Resoarer Toolkit. Resoarer Toolkit is similar to serverless in the way that it also provides you with tooling that reads YAML files and deploys something to somewhere. But it also provides you with some foundational libraries, which we are building to provide event management between different components. And we have this manifest, huge manifest here. This is the last slide, I promise. So in our opinion, project design should be event-oriented on all levels. So even if you have monolithic application right now, you can actually design it in that way that instead of calling functions from one module to another module, you can dispatch an event. And this event can be consumed by multiple instances. And it's really similar to how SNS works in Amazon. And this allows you to decouple your application from the very beginning. Even if it's a monolithic application, it will be decoupled already. And it will be really easy to just take a part of this application and deploy it as a function. Or take a couple of the functions, just module, and deploy it as a microservice. And at any point, like when you run it locally, it just runs like a monolithic application. You don't need to run any tooling around it. It just works because all of the tooling, all of the queues are already there on your Python, Java. We have queues, right? We have ability to inter-process communication, even, which is easy. So what we want to build and what we are building is the software development kit, which would allow you to also declaratively define the project, define the services inside of this project, define the features inside of these services, so we can toggle them on and off. But it can be implemented as a single monolithic applications, if you really want to. And in our opinion, it is probably better to actually start from monolithic application, develop sub-features, test them, fix bugs, provide integrational tests and stuff like that. And then the deployment part on how you actually deploy different components, how many of them you are deploying, how different components are scaled, should be done by deployment system, not by you. Your design should not be dictated by Amazon, for example, or any other provider. If we can do it, if we can provide you with the set of instrument libraries and tooling, so you can also, for example, easily visualize all of the relations in your project locally. You can see, okay, this service talks to this service sends those types of messages to another one. It's nice. You don't worry about that. And yeah, if you want to deploy it to Amazon, sure. So idea is similar to what serverless does, but the approach is quite different. We are starting from local development. We are starting from monolithic applications because, to be honest, most of the projects that we are building, even right now, can be done monolithically, and they don't need to scale that much. They don't need to actually be able to scale for million and billion of people. It is the reality, and a lot of customers, even in our company, spend a lot of money to actually build serverless or microservice architectures when they don't really have to do it. And they come to us with this pile of services and say, well, now can you please help us to support this? And we think, well, it's easy just to, you don't need all of this. You can simplify it really well. So yeah, I really hope that we will be successful, and we have some results already, and as soon as we will again notify everybody, and the project will be open sourced, MIT license, so everybody can use it. It is not bound by any legal aspects because we are not reusing any code which we use for our customers there. It's basically my own project and mine and some other guys. So I hope that we will be successful with this quite soon. Thank you so much for coming. Sorry for the long presentation here, but Amazon is huge again. If you have any questions, I would greatly appreciate if anybody still wants to ask something. Mm-hmm.
Okay, in the demo, in the file you showed us, can you define HTTPS protocol like SSL, or just implement it all the way?
You don't care about that. Your gateway server treats HTTP and HTTPS on that level. and it doesn't matter. On the lower level, you don't think about even if it's HTTP or HTTPS. On the level beyond the HTTP gateway, it's all an event already. It's not even HTTP request anymore.
I want to make a request like delete instead of post, which is defined like post. Is that one possible?
No, because your configuration will not allow this. It will not be forwarded. Any other questions? Yes?
Wait.
Actually, two questions, if you allow me. First one is how do you manage schema versioning in relational databases? And if you have any experience with concurrency walks, again, on tables on relational database, it's a huge problem. Something like we have a bunch of transactions which are concurrently changing common source. So if you can just share your experience on this.
So basically, I guess, if I understand this correctly. So first question is, what about, how do we version schemas in relational databases? Well, it's a really hard question, and it has a lot of answers. First, sure, thank you, man. So we have a lot of tooling around each particular database, first of all, which can help you with that. Next, if you use ORMs, they support migrations, and for relational databases, migrations are basically how you manage schemas. If you have something like Alembic, so another tooling which is specifically was designed to version schemas, you can use that. For us, it doesn't really matter too much, honestly, because the idea of the schema in our system is not about database even, it's about event. So you have two services. One service sends event to another service. This event could have some schema, and it's not even necessary for it to have a specific schema. But we don't care about the schema of the database we get this event from. So you have the service which is directly connected to the database and connected to other services. So after you have this strict connection with database, this is the place when you are managing the versions. For example, database schema might change, but the outside of API of this microservice will still stay the same, and vice versa. So service is responsible for maintaining the schema of the database, and service can use existing tooling like Alembic to do that. And pretty much that's it. For us, it doesn't matter. You can manage it whatever you want, and however you want, and however is suitable for your particular database, actually, if you use some ORM as well. And another question was, how do we concurrent requests, right? How do we deal with concurrent transactions and stuff like that? Well, in similar fashion how DynamoDB does that. So again, for us, it's not it's not the place where actually should do much with that. It depends on how many instances of service which directly connects to the particular database is needed in your system based on the amount of traffic, basically, amount of queries that you want to do. And again, you manage this on one service layer. In Amazon and DynamoDB, it is quite easily configurable dynamically, amount of requests. And locking and stuff like that, well, I guess it also depends. It's really like open question. We have thing called eventual consistency exists. It is mostly for document-oriented and non-relational databases, but it can be applied for relational databases as well, because if you need that, sure. But generally, if you have a lot of scenarios when you have locking for your relational database, something is wrong with your design. You can shard it, for example. And for us, again, it's not about, like, Resoarer is not about databases at all, about how do you configure your sharding for databases. It's not even about, even in serverless, it's not about that. It's about DynamoDB, for example, or a particular configuration. But what we can do, we can pass your configuration from the definition of our service, like serverless does, to the actual provider, which does it. So we just pass parameters, and then how provider will say you have to do it and you should do it. That's how you should do it. We are just passing configuration over. Thank you. Anything else?
So the API gateway, what does it call the next function with? Does it call it with the request in JSON or something similar?
It depends on how will you configure it. Actually, it may serialize it for you. It may unserialize it for you already, so it will be called with an object. But generally, just a payload as a string, and you have to serialize it, unserialize it yourself. At least with this in serverless, in this configuration with API gateway, the default would be just passing the payload as a body, content body, as a string. And that's why you have JSON decode there as the first thing. But of course, it also sends your request parameters already as an object. For example, query attributes are an object, and if you have a schema for your URL, it will also extract those parameters from it and send them separately from your body, of course. But again, it depends on the implementation and plugins there. You can change it. You can do a binary send if you want to. Of course, if you want to manually decode it and save some resources, I guess. But again, it depends on the actual implementation even and of the language of your Lambda function is implemented with.
So to play with serverless Lambda functions, this way would be something like kubeless.
Yeah, they would be kubeless, and it will give you some pain. If you are on Windows, especially, you will have a lot of issues. If you just try to follow the guide that they provide, you will probably have more issues that you want to. First of all, don't use Docker for Windows. Use the old one with VirtualBox. Hyper-V does terrible things to your Windows installation and to your networking. Like this poor notebook suffered a lot in the last couple of weeks with that. I tried a lot of different things there. Man, so you have this tool called Minikube. This is how you run kubeless, basically, and it is not great for your Docker, and so be careful with that. But yes, it will work. It will run your local kubeless will run your local Kubernetes cluster, and you can deploy Minikube to run this and deploy functions with serverless into it, and it will work. But it will work quite slowly, unfortunately, because it will spin up Python, for example. I tried with Python and with Node.js. It took like up to 10 seconds to invoke a simple hello world function.
Well, in the end, behind the scenes, it spawns a
Yeah.
container which executes your code and returns the results.
Yeah.
At least that's the way webtasks
Yes.
and Auth0 do it.
Yes. Webtasks actually another thing that I would suggest trying. Webtasks is interesting because webtasks actually also focus on UI for developer, and they have this in their mind as well. That's why I love this company. It's the same company actually which created Auth0, and you can go to their website, just register the account in 2 minutes. They ask you for how do you want to use it, and you will have free 29 days of testing, and it will still work after that, but you will be without primary features there. And they even have online editor for your function, so you don't need to even download anything. You just can run it in cloud completely. Develop your function in cloud, deploy it to cloud, and it will work free, which is nice. But in practice, it's nice to play with. Practical aspects of that still seem quite vague. Even though a lot of big companies are successfully reporting that they are using that quite successfully. We'll see how they will say and what they will do in next 3 years. Same companies reported the same thing about serverless before, and now are they about microservices. Right now they are all serverless. So we'll see how it works. But I can see the, like the design issues here. Like, it's not gonna work in any case, in any scenario. And the major mistake that you can do is to just design your architecture, whole architecture around serverless and try to do everything serverless, everything in lambdas, everything like that. Yes, it will scale indefinitely on every layer that you want, and it will be super but it will require a lot of things, and it will be really hard to develop and maintain it locally. The new developers will look at it and say, like, what is this? Like, why do we have to create a module for a simple function and create this amount of configuration for it? Why? It was so easy before, like Django, method, it works. So yeah, that's why we want to build a set of tools which will allow you to try to get the best of both worlds. Try to run it locally, try to write simple code, and it will look like it is a monolithic application, but it's not, because it was designed with microservices in mind and with lambdas in mind. Basically, our application is your Amazon stack. It has all of the tooling inside of it, and at any point, each component can be replaced with something that is provided by third party. And that is, I think, how you should design your software right now, in my opinion. Thank you.
So you end up productless.
That's a